everyone. Welcome back to another lesson. For today, we'll be looking at evaluating trig expressions. At this time, please get prepared. Please place your math notebook, laptop, graphing calculator, pencil on your desk. Please make sure you have your Google Classroom open, your Google Forms and handout ready, so that we can get through this with good standing. Also, please make sure that you update the heading for today, which is lesson 9.04. You have the date and the title, and you're ready to go. As usual, this will be the Think About It section. So please take a second and get everything in order, and then we'll move on. All right. So the aim for today's lesson is to find and compare trig values using reference triangles. These are the same reference triangles that we started out looking at in lesson 9.02. And today we're going to keep building on that same concept. Okay. Now my daughter is here with me, so if you hear someone in the background, that would be her. Okay, so the Think About It section has a question that says, use the unit circle at the right, this one, to identify the reference angle in degrees and in radians that would be used to find each of the following. Explain your thinking. Okay, so for part D, it says the cosine of 13. So let's write down first one, part D, cosine of 13 pi over 6. Okay. Now we need to find the angle that would be a reference. So if we were going to use our unit circle to find out what answer this would give us, we need to find what angle we would use to do that. Now, the angle that we would use, we have to change this into degrees to see what angle that would be. So let's change it into degrees. So this 13 pi over 6 to degrees would be taking this number and times it by our conversion factor. Remember that our conversion factor that we'll use is pi over 180 or 180 over pi, depending on what we're looking for. So since we're looking for degrees, okay, daughter, here, take a piece of paper. You can go right. Okay, so pi over 6, pi over 180. So since we're looking for degrees at the top, we want degrees up there, and we want the pi at the bottom. So this must be 180 over pi in this situation. Okay, so pi and pi will cancel. Now we do 6 into itself 1, 6 into 180, 30 times. We do 13 times 30. Just pull out your calculator. 13 times 30. That gives you 390 degrees. Okay. Now, if you notice, in the unit circle goes from 0 all the way around to 360. There is no 390 on your unit circle. How would you find out which angle to use? Okay, the angle that we would use is by, how we would find out which one is by taking a look at our sketch. So if you sketch this, 390 would be going around the circle one time, and then coming around And what is left when you come around? From here to here is 360. So what's left over? So to calculate what that is, we would do 390 minus 360, and that should give us 30 degrees. So this angle here that we're going to use for our reference is going to be 30 degrees. Okay? The question also says that we should have it in degrees and in radians. So now that we know it's going to be 30 degrees, we need that 30 degrees in radians. So we go 30 degrees times our conversion factor again. But this time, degrees are going to be on the bottom because we want it in radians. Okay, so this is 180 and pi. So degrees cancel with degrees, and we can cross off our zeros. 3 goes into itself one time. 3 into 18 goes 6 times. So this will be pi over 6. So we have two answers. We have pi over 6 in radians, and we have 30 degrees. Okay? So both of those would be our radians. Let's take part E. This one says tan of negative pi over 4. Okay. The question is not asking us what tan of this would give us, the coordinates that would give us. It's really asking us what reference angle would we use. Okay, so this part here is kind of irrelevant. The only part that is necessary is the radians that we're given right here. Okay, so we need to take this and, just like before, change it into degrees. So this would be pi, negative pi over 4 to degrees. So we need to change it using our conversion factor. Once again, since we want degrees on to be our final answer, we have to put the degrees on top, which is 180, and the radians at the bottom, so pi. Pi and pi cancels. 4 goes into itself 1. 4 goes into 180 45 times. Okay? So the degree that we would be using, our reference angle, would be 45. Okay? Now that we know that our reference angle is going to be 45, we need to change that into radians. Okay? So to change this into radians, we would use okay, so we know that this would be 45, and the radians is already given. Okay, so we would have or pi over 4 as our radians. Now, is there another angle that we could use for 45? Well, technically there is another one. We could do 360 minus 45. Okay, and when you minus 45 from that, we end up with 315. Okay, now this 315, if we sketch it, would give us the same reference point. So 315, oh, I'm sorry, it's a negative 45. Okay, so this 315 would give us the same thing, because we would start here and make ourselves all the way around somewhere. This is 90, 180. 180 plus 90 gives you 270. So 315 would be somewhere over here. And if you do a negative 45 would just start at 0 and go backwards to there. Okay? So both of them would have the same thing. Okay? So we would have 315 as an alternative method. And now to change this 315 into radians, 315 into radians would be doing 315 degrees times our conversion factor. Just like before, we would put the radians on top, since that's what we're looking for. And we would put the degrees at the bottom, which is 180 degrees. And what number can go into 180 and 315? I'm thinking 45. So let's do 315 divided by 45. Yes, it does. Okay, so 45 goes into 315 7 times. And from before, we know that 45 goes into 180 4 times. Okay, it should be a 4. So our answer should be 7 pi over 4. Okay, so we should have 4 different answers. We should have the original negative 45 degrees and negative pi over 4. Okay, okay, go. And we should also have the alternative, which would be 315 and 7 pi over 4. Okay, as radians. Now let's take our last one, part F. It says sine of 40 pi over 20. Okay, so let's change it again. 40 pi over 20 times the line. We want to have degrees. So degrees go on top, pi go to the bottom. This is our 180 over pi. We can cross off some zeros. And now 4 divided by 2 is 2 into itself 1. 4 divided by 2 is 2. 2 times 180 gives you 360. Pi cancels pi, and we have 360 degrees. Now, what else do we know about 360 degrees? We know from our little sketch that going right around the circle one time is going to be 360 degrees. Okay? 360 degrees is the same as 2 pi from our very first lesson. Okay? All right? Now, this will conclude our Think About It section for today. Hopefully, this was able to help you and my daughter didn't distract you too much. Please make sure that you leave a comment in the comment box below, letting me know what was clear and what was not clear. And I will see you in class in just a moment. Bye-bye.